Hey everyone, today we are going to continue looking at how to show visual representations of parabolas, in other words graphing, but today we're going to look at a different method using something called the vertex method. And you'll see it has some pros to it that make it a little bit easier in some ways than standard form, but there are some drawbacks to it as well. And then we'll look at how to kind of work between both vertex and standard form and convert between the two. So vertex form looks like this. This is our formula for vertex form. Y equals a, and then in parentheses, x minus h and plus k. Now some of this should look pretty familiar. The minus h and the plus k looks very similar to what we did with absolute value functions. So the nice thing about vertex form is that when I look at vertex form, I know exactly what my vertex is. I don't have to do any math behind it. It's given by hk. Now notice that h has that negative sign in front of it. So that means that I'm going to do the opposite sign for my x coordinate, and then the y coordinate is whatever is added or subtracted at the end. So here we go. We're going to find our vertex first. So my vertex is going to be the opposite sign, so -1, -4. And this is where the pros of using vertex form really come out, where we can see, oh, that's kind of nice. I don't have to do the x equals -b over 2a and then plug it in, all that. But here's where the downside is, because we still need 5 points, so you're going to find another point. We cannot use this number here at the end and say, oh, that's our y-intercept. What would happen if we said that -4 was our y-intercept? If we said -4 was our y-intercept and I graphed that, my point would be right here and it would make a straight line, and that's not what we want. So I'm going to pick 2 points. I usually just pick 2 points to the left or 2 points to the right. So I could plug in -2 and -3, or I could plug in 0 and 1. I'm going to pick 0 and 1 just because I think that those seem a little bit easier. So I'm going to plug in x equals 0, and that's going to give me y equals 2 times 0 plus 1 squared, minus 4, not plus 4. All right, so this would give me y equals 2 times, that would be 1 squared, so just 2 minus 4, and y would equal -2. So I'm going to graph this point, 0, -2. And that makes a little bit more sense. But I'm also going to graph its reflection. Even though we didn't state what the axis of symmetry is, we still can by looking at this graph. Remember, the axis of symmetry is the vertical line that goes through our vertex. So my AOS would be x equals -1. I know that right now it doesn't say to label that, but if we needed to label it, that's what it would be. So we're going to put another point over here because I graphed the reflection. All right, next I need one more point because I need 5 points total. So if I plug in x equals 1, then I'll have the value at x equals 1 and its reflection, which gives me a total of 5 points. So I'm going to get y equals 2, and then 1 plus 1 squared minus 4. Y equals, this would be 2 times 2 squared. Well, 2 squared is 4, and 4 times 2 is 8. So 8 minus 4, and y would equal 4. So my next point is going to be at 1, 4. That would be right here. Graphing the reflection, it would go over here. And what I see is that I do still have my parabola shape, so I can make my curve. Oops, that is a not good curve. I'm being a little perfectionistic, sorry. I know I said it doesn't really matter if it's perfect or not, but sometimes I just want it to look so nice. All right. Oops, I did not mean to do that. Oh well. There we go. Sorry, had a little OCD moment. So I want to make sure that it has a curve. It's not making, like I said, like a V shape. It should make a curve, but that would be our parabola. So let's try one more. What would your vertex be here? The vertex would be -1, -2, because I changed the sign of the first one and keep the sign of the second one. So my vertex is at -1, -2. But what's the axis of symmetry then? The axis of symmetry is whatever your x-coordinate is. So it's going to be x equals -1. And so then I can put my vertex right there. All right. Next up, we need to find 2 points. Again, I like picking, if 0 is an option, I like to pick 0. So I'm going to pick x equals 0. And we get y equals 2/3 times 0 plus 1 squared minus 2. And unfortunately, picking 0 every time doesn't necessarily work the best, because as you can see, we're going to end up with a fraction, which we can do. This would give me 2/3 minus 2, but if I want to put that as over 3, I would do minus 6/3. 6/3 is the same as 2, so this would give me y equals -4/3. So I'm going to have 0, -4/3. So that's like negative, about here. It's like past -1, but not to -2. All right, so if I don't want to have to work with fractions, what's a value of x that I could plug in that would make sure that I don't get a fraction when I'm working? In order to not get a fraction, if I plug in a value of x that makes this number here be divisible by the denominator, then I'm going to not have a fraction. Because if I plug in x equals 1, I'm going to get 1 plus 1 is 1, or 2, excuse me. 2 squared is 4, but that's not divisible by 3. But if I plug in x equals 2, let's see what happens. I would get y equals 2/3 times 2 plus 1 squared, and minus 2. So this would give me 3, and 3 squared is 9. So y equals, and when I do this, I would say, okay, that would make a 3. So I would have 6 minus 2, and y would equal 4. So my fraction gets canceled out, and my final answer would be the point 2, 4. So even though I skipped x equals 1, that's okay. I don't have to do them in order. I can kind of pick points that will allow me to have whole numbers if you want. I could also plug in like x equals 5, because 5 plus 1 is 6. 6 squared is 36, so that would take care of it. But the problem you're going to run into is that it might go off the graph. So sometimes you'll have to just deal with the fractions. Other times you'll be able to cancel them out. Okay, so there we go. There's our parabola. But there are a couple of other things we can do with vertex form. Vertex form makes it easy for us to write the equation of a parabola, or easier, I should say. So the vertex is the maximum or the minimum. So what is the vertex of this parabola as an ordered pair? The vertex is this point right here. So paying attention to what we're counting by, it looks like since this is 2 and this is 4, that means that right here would be 1. That means that this would be -1, -2, not that one, and this would be -3. So my vertex is at the point 2, -3. Now, unfortunately, that's not enough, because if I go y equals, I don't know what this value of a is. I do know that I've got x minus 2 squared and then minus 3. Notice I changed the sign of the x coordinate and left the sign of the y coordinate the same, but I don't know what this value here is. So what I'm going to do is I'm going to pick another point on the parabola and I'm going to plug it in. I'm going to look for somewhere where it crosses. Actually, right here, this y-intercept is perfect because this is at the point 0, -3. And so I'm going to plug in that point to this unknown, and I'm going to find the value of a. So -3 goes in for y, and 0 goes in for x. And now I'm going to use order of operations to solve for a. 0 minus 2 is -2, and -2 squared is +4. So I end up with 4a minus 3. Add 3 to both sides, and we get 0. Wait, I did something wrong. +3. Oh, I know what I did. Okay, so I put -3 up here. I was counting the wrong way. So this should be, this should be a -5. I'm sorry. So then if I plug in, there we go. So that'll fix this problem. There we go. That makes more sense. I was like, we can't have 0 for a. All right, so that means that we're going to end up with 2 equals 4a. And then when I divide by 2 on both sides, I get a equals 1/2. So my final equation would be written as y equals 1/2 x minus 2 squared, and then minus 5. Sorry again about that little mistake, but that would be the equation for our graph, and we can leave it in vertex form. But sometimes we're going to be given standard form and asked to change it to vertex form. So the first thing we're going to do is find the x-coordinate of the vertex. So do you remember how to do that? With what formula are we using? We do x equals negative b over 2a. My a value is negative 3, b is 12, and c is 5. So I'm going to get x equals negative, and then 12 over 2 times negative 3. That would be negative 12 over negative 6, which is positive 2. So x equals 2. And then find the y-coordinate of the vertex. So we've got the x equals 2, so I'm going to do y equals negative 3 times 2 squared plus 12 times 2 plus 5. And we're going to have y equals 2 squared is 4, negative 3 times 4 is negative 12, plus 24 plus 5. So this would give me 12 plus 5 is 17. And now, if we think about it this way, we've got the formula for vertex form looks like this. I know what a is because I have it up here. This a value is going to get brought down, so I'm going to have y equals negative 3, and then x minus the x-coordinate squared, and then plus 17 for the y-coordinate, because the sign stays the same for the y, changes for the x. And this would be the equation in vertex form from standard form. So that's what we're going to look at with vertex form today. Check Google Classroom for homework assignment, but as always, let me know if you have any questions that I can help you with.